As you already said, the title of my talk is Not So Smart on Smart TV Tech, and obviously it's about smart TVs. And before we will start, just a few words. There are also some other guys who did this work. One of them is sitting over there and eating with a black shirt. Say hello, maybe. Yeah. And this is Juraj, and yeah, I'm Marcus. We are all from the Ruhr University. We are also all from a company which is called Recurity or Dreicurity, we say that in Germany. And what we do is, and I don't wonder why it doesn't work here. Nice. Okay. Perfect. So, nee, so what? So I'm from the Horst Goetz Institute for IT Security, which is a part of the Ruhr University in Bochum. And the cool thing is that we thought, hey, wouldn't it make sense to do some pen tests and security trainings as we did in the last 10 years? And this work is actually more or less a pen test, and a very in-depth pen test because it took about 4 months, at all. And yeah, we are actually web security experts or browser experts, and this is the reason why we took smart TVs, because we are using browsers, but you will see this later on. And you can also find me on Twitter and so this kind of stuff. So this is how the table of contents looks like. We will begin with an introduction and a generalization. So we will see that these attacks are also transferable to other fields, to other products. Then we will see what devices we have tested, what's the attacker model, an eavesdropping scenario, which is very, very trivial, but it has so many crucial errors. Then we go in depth into the Samsung smart TVs. It affects all smart TVs since 2012, so it's very, very nice. And last but not least, there is a conclusion section with a little bit of lessons learned. So what can we do to have some countermeasures? So introduction. All of us know that years ago, as TV was just a TV, so we used it to look on some movies, and it was quite a trivial device. And nowadays, it's actually a computer. And one function of this computer, which is running in most cases Linux, is the TV function. And as smart already indicates, it interacts with something, in general with some servers, and thus we have also an internet connection. So a computer with an internet connection, this might be good for a remote attacker maybe. And when we look on apps in general, not only smart TV apps maybe, we can see that we have social networks where streaming services are very, very popular with a high traffic on the internet. Games like Angry Birds even, so I can play Angry Birds with a remote console, which is quite nice maybe, who knows. And I can browse websites with it. So the cool thing here, or actually the worst thing, is that the browser version is out of date because manufacturer like Samsung doesn't update his browser frequently. This is only in Chrome or Firefox nowadays the case. And if we have a look on devices for the generalization, where we can transfer the attacks, which I will present in the next slides, we have a few requirements to transfer them. So first of all, an internet connection, and then an app rendering engine. In our case, maybe an app rendering engine from a web browser, because this makes sense from the browser security perspective. And last but not least, an attacker's app which is in some way installed on the device. For example, in our case later on, we can plug in a USB device into the TV, or we upload a malicious app into the App Store, and the victim downloads this app. So there are several ways to do it. And when we look on other devices besides smart TVs, we can see that we have, for example, BMW Connected Drive. So we are able to use Twitter while we are driving. Such important. And also Napster, Wikipedia. I mean, why? And also here, the Google Car to Play or Android Car. You can see here what you need out on the road. Is Skype or Spotify, ICQ, and what else? Threema, of course, very, very important at the time of Internet of Things. And this was also totally hyped the iWatch or the smartwatches in general. And even a fridge has nowadays apps. So we can write SMS with it, we can look on the weather. I don't know why, but yeah, you can buy this device. And of course, if a guy presented that a few minutes before, we have a smart home nowadays, which is maybe in some case possible. And even this smart home can have devices which, including apps. And last but not least, of course, smart TVs. And when I saw this website, I thought, can this woman, maybe we as a consumer, as a customer, and this may be Samsung, and Samsung says, hey, buy my devices, buy them, because they are totally secure and they make you happy. And we as a consumer, we say, I actually don't want this shit, but I buy it, so shut up. Yeah? And we will see that this is really the case. So, tested devices. What we did is that we bought the top 5 devices due to their market share situation. So top 5 from the manufacturer perspective. So first of all, Samsung, which has a market share of 30%, I think in 2014. Then Grundig, because Grundig TV was owned by Uri. Apple TV, without an app store, so the model from March 2015, Google Chromecast, and Amazon Fire TV. And what we did is that we updated each device so that there are no missing fixed vulnerabilities maybe. So they are really up to date. So our attacker model, what did we do? First of all, from a trivial perspective, we have an eavesdropper attacker. So this is actually man of the middle. What we did is that we have opened unencrypted network and said, hey, I will listen to the packets which fly around and see what's in there. You can also do this if you have a hardware, what else, or router. It depends on your setup. Then we have the attached storage attacker. This means an attacker who gives you an USB device. Or you find a USB device and say, hey, it's a good idea to put it into my TV because there's a movie on it and I can see it. And the other attack, this is attack number 3, is the malware attacker. So we as a victim go into the Samsung store and say, hey, that's a calculator. Wouldn't it be a good idea to have a calculator on the TV? Sure, and you download it because it's just a calculator, right? So first of all, the eavesdropping attacker, and then we move on. What we saw is that we analyzed also the top 5 apps of each category in the Samsung store, 56 apps, and 16 of them have a login option. So you type in your username and password into the app. And 4 of these apps here are vulnerable. This means they do not use HTTPS, so no SSL or TLS. Grundig, the same. So 34 apps, 7 apps with a login, and 3 are unencrypted. And Apple, just 1. Google did it in the right way. They always used, as far as I saw that, TLS 1.2. This was quite okay. And Amazon was new at this time, so maybe this was the reason why we didn't find any app which was infected. So let's zoom in. From the 25 pre-installed apps, in the case of our Samsung TV, there were 2 apps which sent their data unencrypted. In the case of a login. WatchEver and ImmoScout. So ImmoScout because we tested the device in Germany. ImmoScout is a very, very popular company there. Then we have tested 35 apps, some were duplicates, for this reason 31 apps in total. And the following apps are vulnerable: NewMove and PutPad TV. In the case of Grundig, Facebook, which was quite interesting, eBay and Viewster transmitted the data unencrypted. I didn't expect that in the case of Facebook, because Facebook is actually using HTTPS nearly everywhere, but not here. Maybe because of legacy reasons, who knows? And we know this company here. In the case of Apple, WatchEver, we saw that already in Samsung case. So whichever ImmoScout, NewMove, PutPad, Facebook, eBay, and User. Quite nice for a simple attack. And while we looked on the log files by using Wireshark, we found something interesting, and I will show you what we found. So I will open it and say, hey, open my sniffed content. And I say, okay, I have a lot of things here. I want to see HTTP traffic. And let's have a look. We have the 101 here, for example. In this case, we say, hey, please give us in an HTTP request the check XML loaded from samsungcloudsolutions.com. Okay, fine, that's okay. Yeah? Then we go on and see, Google Analytics. Oh, okay, I'm watched somehow by Google. That's okay nowadays, maybe. Vevo playlist, because we used the Vivo app here. Yeah, so we watched a music video. This is why there is Vivo in it, the Vivo app here. And if we go on, for example, here, where is this? Vivo playlist live. And in one case, let me load it up, it was the case 9655, where we have it here. We saw this. So obviously, I'll zoom in into the URL here. We have an HTTP request to scoreboardresearch.com. And we surfed on this website, and what we saw was a little bit surprising, because Scoreboard Research tracks you. So they track, hey, you are watching the video of Jennifer Lopez or Mariah Carey and 1 minute free, and you watched it for 2 or 3 minutes. That's quite okay, but let's look a little bit deeper inside this request. Yeah. So we look on the parameters. What we see here is, okay, we have a parameter C1 equals 2, okay, widgets, that's also okay. Then index HTML country DE, okay, he knows that I'm from Germany. We go on and go on. We have the version number, and what we see now is what? Single sign-on ID Markus Niemietz, that's my name, at rup.de, and single sign-on password. I don't show you the rest. Yeah, I will switch now to the other window. So this is better, at least better for me, part of the request. What we see here, where is it? Foobar or something written there. Here. So we have my name, my email address, and a single sign-on password, which I changed to secret, and an authentication token. And I thought about, hey, single sign-on ID with my username and my password? Where's this password from? And this password is actually from my TV, because I'm using Samsung Smart TV services. So I'm using the Samsung Cloud. I can control my Galaxy phone with it. And Samsung thinks it's a good idea to transmit this data to arbitrary apps or app vendors. Yeah, really surprising. So first of all, the app vendor can de-anonymize me, which is quite privacy critical. And of course, they can log in with these credentials into my account. And any attacker which is sniffing my connection, because it is transmitted via HTTP. So let's go on. It will be even better and better. So we have our Wireshark window and the credentials here. And what is written on the webpage of Scoreboard Research is, Scoreboard Research, marketing research community, a leading global market research effort that studies and reports on internet trends and behavior. Scoreboard Research conducts research by collecting internet web browsing data, okay, nice, and then uses that data to help show how people use the internet, what they like about it and what they don't. So why do you have my credentials? For what? Yeah? And we looked in with these credentials into the Samsung single sign-on world, in the whole Samsung single sign-on environment, and what we saw was, hey, I can install remote apps with this website here, I can directly access with the help of a Java applet to your Samsung cloud, so I can see what you have saved on your computer, on your laptop maybe. We see that it even recognizes what you have written with the Samsung pen, Samsung Health, so if you have some fitness sticks, they can see what your heartbeat is maybe because of a leakage, who knows. And you can also go to the Samsung stores, so you can see credit card data there, your address of a victim and so on. So more or less you can hack, in quotes, the complete environment if you have this kind of data. And what's in there is, as I already said, the Galaxy apps, Samsung Link, Find My Mobile, so you can see where your victim is right now, smart appliances, Samsung eStore Pen App, Samsung Wallet, so there are stored credit card data and coupons and such things, Health, the Samsung Cloud, so all of the things which are connected with Samsung, because Internet of Things is cool and Samsung makes it in a right way. So, and we thought, okay, the situation is really, really bad in the case of Samsung because of this finding, and we look a little bit deeper on Samsung smart TVs. And I thought about, hey, wouldn't it be nice if Samsung apps could be used to compromise the TV in some way or compromise the victim who is using this TV? And a Samsung app is actually just a website which is loaded by parsing the config XML. The config XML just says, hey, I have this version, my name of the app is this here, this is my icon, and by the way, please open the index.html file. And the index.html file can include cascading style sheets, JavaScript, and what else. So a normal HTML5 supported app. And the cool thing is also that it supports a USB device. So if you have a folder where config XML is stored on, it will be automatically recognized as an app by just putting in the USB device into your smart TV. And because we were actually browser experts, we thought, hey, okay, let's try out some things in the DOM, in the document object model. And what we thought is, what's about the user agent? Navigator.userAgent, okay. And the output was Mozilla Smart Hub Smart TV, Linux Smart TV Maple, Apple WebKit, okay, Smart TV. So Samsung changed somehow this kind of string. So at least they implemented or added Smart Hub into this string and Smart TV. And obviously it's also a Linux-based system. Okay, nice. They changed the browser. What could go wrong, right? And then I tried out document location to see, hey, what's actually the file which we opened? And what I saw was really surprising because just once again, automatically added my single-sign on account and my single-sign on password. And I never expected that it will be transmitted or shown if I use document location, but because it's actually the URL or the URI when you are in a file system. What you can also see, by the way, is the real model number and some other things. So you can also be clearly de-anonymized in this case. So bad enough, this is maybe the reason why we transmitted data to the Vivo app, because they used, obviously, I think, document location. And then we tried out some HTML elements to see, hey, is Samsung maybe smart and they think, wouldn't it make sense to forbid some elements for security reasons? And indeed, they did. They disallow the usage of iframes. And maybe some of you know, I actually really love the topic of click checking and UI addressing. And I thought, no iframes, so I cannot do the classically click checking attacks. What a pity. And I ask you, who of you knows an element, or rather two, who does the same as an iframe in the HTML context? So for us, it can load a website in it. Who knows that? Object, perfect. So you have a first bypass. We took that here. So we say object class, iframe look, type text HTML, data, and we have our iframe functionality by loading an arbitrary URL, which is on the internet. Nice. I looked that up with the help of Google, and what I found was very interesting. In the Samsung developer board, there was written that the iframe element was forbidden because of security reasons. So obviously we can bypass it, so why? Why security reasons? And the answer is this nice thing here. With the help of the object element, we were able to use the file protocol. So we put in file here, and thus we can also access the Samsung file system. So we have access to the smart TV. Yeah? Even worse, we have root-like access. So we can read all the files which are stored on this smart TV here. And yeah, we built this app. We can put in here a path, a file name, we can directly open it, and we also said, it's a little bit complicated to read long files on a smart TV, so we want to transfer them to our server, to the attacker server, and thus we have a little bit AJAX functionality, which we implemented. And we use two kinds of transferring data. So first of all, the AJAX thing. So what we do is that we read the file and send it to the server. And the second one is XXE, so XML external entities. And what we do is that we can read out automatically one line of code. So for example, we are able to read out automatically by just plugging in the USB device into the TV or just having installed a malicious app without opening it. Yeah? The version name or my Samsung single sign-on ID, which is saved here. And this is how the attacks look like. So, for example, we have XXE. We say in the config XML, which is truncated here, please open this file, so which is in this folder here. And after that, you should parse the attacker.xml file because of some entity stuff. And what we do here is that we are requesting a URL which does not exist, or a file which does not exist, and this not existing file name is the payload or the content from our hijacked file of the file system. So we are requesting a file which is named because of the content here. This means an attacker who looks into the error logs is able to read out any data if he's able to change something here in this attribute, or in this double quotes here. So what kind of files can we access? So first of all, we can access Wi-Fi data. So there is written, hey, you have this hotspot, it's this name, and of course, here's the password in clear text. So every time when I go into a hotel and there's a Samsung Smart TV, I put in a USB device and I have the Wi-Fi password. Then app cookies, browser cookies and app cookies are accessible. Local storage data, of course. Yeah? So we were, for example, able to steal the login data from the Zatu app. Then we have it already, the Samsung single sign-on username, the browser history, and common user inputs. This means if you are using a Samsung TV, it automatically stores each user input into a file, and this file ranks your user input. So when you put in your username or even your password, it will be stored there. Yeah? And on place 1 and place 2, yeah, there was my username and my password, because these credentials are, in most of the cases, my common user input. And we were also able to partially access the webcam, so we can see some webcam logs. We have some API possibilities here. So actually, we more or less are able to control the smart TV in some way. What we also found is OAuth. So we were able to read out OAuth API keys and API secrets, for example, from Facebook. And just once again, as a reminder, OAuth is it is written not to log into the user internet application, but to grant access rights on specific resources to it. So it grants access rights. Thus, we were able to spoof a client, but we are not able to steal credentials. But however, we as an attacker are able to go to Facebook and say, hey, I am Samsung, and I can authenticate as Samsung, which is quite nice. And the most important thing here, this API key is probably installed of millions of devices, because it's a static key delivered by Facebook. And here's the proof. Yeah. So we verified this, it really works. It's a static JavaScript file, and in this JavaScript file there is written the API key and the API secret. And what can you do if a victim thinks, hey, you are really a Samsung app or a Facebook app from Samsung? So, for example, you can see the public profile of a victim, the newsfeed, the timeline, the relationships, the photos, the friends' websites, nearly all of the things. You can even do a post on the timeline and send notifications. So actually you control, in some cases, the whole environment of a victim here. And I just want to say it's actually a never-ending story in the case of Samsung, because there were several attacks before. For example, Samsung smart TVs had some problems with their voice recording. So when you are in front of your smart TV, there is maybe a chance that it listens to your commands, and these commands will be transmitted to Samsung, so they know what you are talking about, at least in the past. This is, they say this, fixed right now. And there was also a nice attack from Colin Molina, which is called read twice, a mass storage-based time of check to time of use attack. And what he did was that we installed a malicious firmware update into the TV. So just by using some tricks, and this is quite nice. So what we see is leaking data is not new. Installing malicious applications is also not new, but leaking credentials to an arbitrary app vendor is new, right? And in the past, several magazines, TV stations, and so on covered this research, this topic, because it was published, I think, 1 or 2 months ago, also Golem and Heise here. And the question is, what happens? What did Samsung do? Because we sent them the vulnerabilities in March, and actually nothing happened. Or, well, it happened something. They do not answer any email after publishing it. So quite nice. And what I have read in the last 2 weeks was that an instance from North Rhine-Westphalia, which is called Verbraucherzentrale, it's the consumer advice center of North Rhine-Westphalia, contacted a lawyer because of some privacy violations on Samsung smart TVs. And this were not our findings. So there are also some other vulnerabilities. And we thought, hey, wouldn't it be cool to get some money because of bug bounty programs? Because when you go on Google or Facebook, there is a bug bounty program, and you get for an XXE attack, for example, about 20,000 euro. And I thought, hey, I can buy a new car for that, nice. But we contacted Samsung, and we didn't get any reward, though it is written here on the page. And I can tell you the reason why. They told us, hey, please look on the website, and there was written, hey, you agree not to disclose the vulnerabilities to third parties without our agreement. So this means I will never have a possibility to publish these bugs if Samsung will not fix them, or will not say, hey, please publish them. So I gave him the chance to fix these bugs within 6 months, I think. And I tested them 1 month ago, and they were not fixed. So, conclusions. I think that we went very fast. We have a lot of Internet of Things technologies, and I think it's a good idea to use them in some way. For example, I have a Samsung Smart TV, and I'm also using Amazon Prime, and I think, well, it's quite nice because it's easy to use, and I have the services, why not? It's a legal thing also, thumbs up. But it's maybe a better idea to change something which should be only changed by experts. For example, if you change a browser, the only person or instances or companies who should change a browser should be Google, Mozilla, or maybe Microsoft, who knows? And when we look on the lessons learned section, we can see, you should use trivial countermeasures like TLS. You should encrypt your data, which is not really new. You should not save sensitive data like Wi-Fi data, which is maybe complicated to fix, and of course user inputs, common user inputs, unencrypted on your TV. Yeah? And even this is also trivial, you should not run with root privileges. Yeah? This is known since 15 years or 20 years. And we have also expected a sandboxing-like mechanism because Google Chrome has a sandbox, and it is also possible to use the file protocol there, but we expected that there is some kind of layer which disallow our access, but it wasn't the case. So they really did all the things wrong, I think. And this is actually for you or for all of us. If you have a Samsung TV or a smart device which has a webcam, you should maybe put a paper before the webcam in front of it to protect yourself, so if you want to be watched. So that's it. I hope you enjoyed it. Thank you.
There's plenty of time for your questions. That's a very interesting talk and shows, I guess, the dangers of the Internet of Things. You mentioned you looked at other smart TVs as well. Did you find similar sorts of vulnerabilities there, or?
We looked very, very fast on LGs, but they are a little bit different. I will not say that they are secure, but they are different, and also Grundig, but the focus was on Samsung because of our privacy violation finding. Yeah. And it took about, at least in the case of Samsung, I think 3 months of evaluation with 2 persons. Yeah.
Is the code for getting the Wi-Fi password out of the Samsung TV public?
I'm honest, I'm a little bit scared to do this. Maybe after Samsung responds and allows this, but they are not even here, so what can I say to that?
Yeah, it would be really cool for hotel rooms to not have to ask non-tech personnel for the Wi-Fi key.
Maybe there's some independent research discoveries. Further questions? Who's got a Samsung TV?
So maybe for the evening, if you want to know what's actually the content of the browser history was when we looked on the TV, you have to drink a beer with me in this evening, because there were some really nice findings. So I can tell you what the Samsung technical guy did with our TV before we received it. Yeah.
That's also a way to see it's actually a new device.
VTV?
Well, if you can look at the browser history, you can maybe see if it's actually a new device or if it's something that was returned to the store and then sold to you as a new device.
I cannot really say that because it was updated, and thus we have also updated the firmware, and this is maybe the version for all of the TVs. So the devices may be old, but the version was new, which was installed.
But like a refurbished device, or that was set up as a demo in a shop, for example, where some customers probably check their Facebook account. So.
By the way, we have tested different Samsung devices, but the model which was described here was tested in dev. So there was no webcam in this model. Just if Samsung says, hey, this isn't possible here.
Get a TV with a webcam, please.
Right.
Any questions? Any more questions? There's plenty of time. Don't worry. There's even plenty of time for questions and grabbing another coffee.
Would it be easy to install your own operating system on it?
You were able to write files on the USB device or attached storage device, but you are fully able to read all the files. So execution is not given in some cases, and write privileges are just given in these mentioned cases. So you're not able to write a new firmware version into the TV. So this is not so easy possible.
Okay, thanks.
Do you know, are you able to deinstall every pre-installed app from the Samsung?
You mean that if I'm able to install apps or what?
Yeah, no, every pre-installed.
I don't know what you mean.
Now, you reported many HTTP
Yeah.
requests, so maybe some of the pre-installed apps are doing also these things.
Yeah,
so
this is
are
true.
you able to deinstall the pre-installed apps coming from Samsung?
Good question. I don't think so. Yeah. Okay.
Okay,
So.
are we good? Looks like it. Well, thank you.
Okay. That makes sense.